Let's take a minute to talk about the algebra of functions. And the algebra of functions just says that we can take sums, differences, products, and quotients and apply those algebraic properties, adding, subtracting, multiplying, and dividing, to two functions. So f plus g of x means f of x plus g of x. F minus g of x means f of x minus g of x, and f times g of x means f of x times g of x. And then for our quotient rule, f divided by g of x means f of x divided by g of x. And we have this little addendum here that g of x is not allowed to equal 0. Well, that's because g is in the denominator, and the denominator is never allowed to equal 0 because we cannot divide by 0. Now, you could also have different functions. You could have h of k, or h divided by k of x. And that would mean h of x divided by k of x. And of course, in this situation, we would say k of x cannot be 0 because that's in the denominator. So the variables are just f and g because we generally use f for a function, and I assume because g comes after f. When you have questions that ask you about finding the domain, which you won't have many in this class, but it's built into some of the problems, the domain of a sum, of a difference, or a product, right? So adding, subtracting, or multiplying. All you're going to do is look at the domain of both the original f and g, and then you're going to find where they intersect or where they overlap. And we have the same rule for the domain of f divided by g. It's still that intersection of those two original domains, but we just include this extra piece. We say, hey, whatever function is in the denominator, in this case g of x is not allowed to equal 0. So I'm just going to jump into a couple of examples and let you know how you would apply these operations to two functions. In this example, we're given two functions. We are given that f of x equals x squared minus 3x, and g of x equals negative x plus 2. And then we're asked to find as well as evaluate g minus f of negative 5. Really, we're just asked to evaluate here, but we are going to do both of those things. We're going to find the difference and then evaluate. We have two different ways that we can do this. So the first thing I'm going to think about is, what is g minus f of x? Well, by definition, since g comes first, we will say g of x minus f comes second, f of x. So that means if I were finding this new function, g of x is given as negative x plus 2, notice my parentheses, minus f of x squared minus 3x. So I used the parentheses associatively to group these two functions individually. And the reason that's important, especially in this problem, is because that minus is in front of all of f, all of x squared minus 3x. And what that indicates is that minus will need to distribute. So now I have, this is equal to negative x plus 2. I have minus x squared and plus 3x. So that second operation inside the parentheses here, that turned from a minus to a plus because negative is positive. At this point, we can combine like terms. I've got 3x minus x, and this would simplify. G minus f of x is negative x squared. Negative x plus 3x is plus 2x plus 2. So now if I'm asked to evaluate g minus f of negative 5, g minus f of negative 5, that just means I'm plugging negative 5 in for x. So negative, we have negative 5 squared, again noticing my parentheses, 2 times negative 5 plus 2. Or negative, that was positive 25 when I squared it, minus 10 plus 2. Now I have negative 35 plus 2, or negative 33. So that's my output value. All right, that's what I get when I plug negative 5 into the difference of g of x minus f of x, g of x minus f of x. Now, I didn't have to find this function first in this problem, but I just wanted to point that out to you and show you how we subtract functions. We could have gone about this slightly in an alternate manner. So I'm going to take these x's out. I'm going to go ahead and plug negative 5, that x value, our input. I'm going to plug negative 5 in at the onset. And so what would that look like? Well, we would have negative 5 plus 2, so all of that, minus my f of x function is negative 5, that quantity squared, minus 3 times negative 5. So I want you to notice here, again, using my parentheses. So negative 5 squared, thinking about just that value. If I type negative 5 squared into my calculator will read that as negative and then 5 squared, or negative 5 times 5. I don't need that extra squared there. So we would get negative 25. Whereas if I type using my parentheses, negative 5 quantity, that's squared, that's negative 5 times negative 5, which gives me positive 25. So, you have to type it into your calculator. If you're going to rely on your calculator and using that tool, you do need to know how to type it in correctly. And the value we get for the quantity, negative 5 squared, is positive 25. So I have negative 5 is positive 5 plus 2 minus, over here I've got positive 25 plus 15, which gives me 7 minus 40, and 7 minus 40 is the same answer we got the first time we did this, negative 33. All right, let's look at one other example. In this example, we are again given two functions, f of x equals x plus 3, and g of x equals x squared plus 5x plus 6. So we're going to use each of these functions, the f of x and the g of x, and we're going to apply some algebraic operations. So maybe A, we might be asked to find f times g of x. F times g of x just means we would multiply these. So that means x plus 3 is my f of x times g of x, which is x squared plus 5x plus 6. And of course, in order to multiply this, we need to distribute. So we'll say x times each of these three terms, as well as 3 times each of these three terms. So that gives me x times x squared is x cubed, x times 5x is 5x squared, and x times 6 is 6x. Again, with the 3, we'll get plus 3x squared plus 15x and plus 18. Simplifying, we've got x cubed plus 8x squared plus 21x plus 18. So in this example, we noticed, or we learned, how to multiply two functions. Part B, we're going to find f minus g of x. And when we are subtracting, order matters. So this means f of x minus g of x. Remember, subtraction is not commutative, so we have to perform subtraction in the correct order. And that gives us, we would have x plus 3 minus g of x x squared plus 5x plus 6. So again, noting that that minus will distribute to all three of those last terms. We've got x plus 3, that would be minus x squared, minus 5x, and minus 6. Combining like terms, we'll have negative x. 1x minus 5 is going to be minus 4x, and 3 minus 6 is going to be minus 3. So there we were able to subtract two functions. Now, addition would work the same way. We would just combine like terms. We wouldn't have to distribute that negative. And for our third part of this example, we'll look at finding g over f of x. And so what we'll do here, that means mathematically, that means g of x divided by f of x, or rather x squared plus 5x plus 6 divided by x plus 3. Now, this is our final answer, and we haven't really gotten to factoring yet. That comes in our next unit. We talk a lot about factoring, but you should be slightly familiar with it at this point, and you should recognize that the numerator factors. We have x plus 2 and x plus 3 over x plus 3. So that numerator factoring, you'll notice that x plus 3 over x plus 3 cancels, and we end up with g over f of x. G over f of x is just x plus 2. So now that's our final answer for dividing the quotient of these two functions. However, we had this denominator here. We said that we had x plus 3 in the denominator. And we should recognize that that would tell us that x cannot equal negative 3. So we would have this domain restriction. So even though if we look at f and we look at g, and we'd say, well, this domain is all real numbers and this is all real numbers because f and g do not have a denominator, they do not have an even indexed root, we would still have to include that because after we created this quotient, there was a denominator. And so negative 3, even though we eliminate it, would still have been a problem. So I hope that helps you guys understand how to apply these algebraic operations to the functions and evaluate them if necessary. Please feel free to email me, get in touch with me if you have any questions or you need extra help, because that is why I'm here. Good luck.